This is the quadratic formula. It reads x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It looks rather complex, but it's a nifty tool to have to solve a quadratic equation. All you have to do is simplify the quadratic equation into standard form, identify a, b, and c, plug the values in, and then simplify. In doing so, this equation will give you the solutions to your equation. An equation that we might look at solving with the quadratic formula would be x squared minus 6x plus 9 equals 0. Now this quadratic equation may have two answers, one answer, or actually potentially no solution. The quadratic formula will yield those answers for us. Let's take a look at the steps. As I mentioned earlier, our first step is to make sure the equation is in standard form. That is ax squared plus bx plus c equals 0. That may be done already when you start the problem, or may need to be done through manipulation of the equation. Step 2 is to identify your a, b, and c values in the quadratic equation. Step 3 is to take those a, b, and c values and substitute them into the quadratic formula in the appropriate locations. Step 4 is to simplify. And 5, verify your solutions that they do in fact make the original equation true. All in all, this is a pretty easy way to solve a pretty complex equation. It requires levels of knowledge that are finding standard form, identifying coefficients, substituting in, and simplification. All things that you guys are very good at. So our very first step here is to identify a, b, and c. A is the coefficient on the x squared term, b is the coefficient on the x term, and c is our constant term at the end. From here, we're going to substitute those values into the quadratic formula. Since the quadratic formula reads x equals negative b, we're going to keep that, plus or minus, we'll get back to that in a second, the square root of b squared minus 4 times a times c, all over 2a. So the whole right side divided by 2a. Because our b value is negative 6, that's going to be placed into the two locations there's a b in the quadratic formula. Because our a value is 1, that's going to be dropped into the location where there's an a, here, and also here in our quadratic formula. And there's just one c in our quadratic formula, and we're going to replace that with a 9, because that is the value of c. From here, we do some simplification. We get x equals negative 6 is positive 6, plus or minus the square root of negative 6 squared, which is positive 36, minus 4 times 1 times 9. 4 times 1 times 9 is 36, all over 2 times 1, which is just 2. We simplify again, and we get x equals 6 plus or minus the square root of 0 all over 2. The square root of 0 is in fact 0. So this simplifies to x equals 6 plus or minus 0 all over 2. What does that plus or minus mean? It means there's two solutions. One of them is 6 plus 0 divided by 2, and the other one is 6 minus 0 divided by 2. 6 plus 0 is 6, divided by 2 is 3, so we have a solution of x equals 3. And 6 minus 0 is 6, divided by 2 is again 3. And so we find the same answer twice. Our solution here is x equals 3. There's just one solution. That tells me that there'd be a parabola that only touches the x-axis one time. And this one time occurs right at the point 3, 0. Let's make sure we're right. We take this 3 and plug it back into the original equation. 3 squared is 9. 6 times 3 is 18. 9 minus 18 is negative 9. Plus 9 is 0. And 0 equals 0. So yes, we are correct. If you were wondering why there's only one solution, refer back to an earlier lesson on using the discriminant to calculate, or predict, use the discriminant to predict the number of solutions.